Less than 2 decades ago, a seismic transformation began to shake the very foundations of Africa. The ground, once stable and unyielding, started to split open across different nations, leaving a man's home torn asunder in its relentless wake. What emerged from this spectacle was a stark reminder that Africa, the cradle of humanity, was undergoing a monumental transformation, a continental rift. This is not merely a geological event. It's a cosmic dance of tectonic forces that could reshape the face of our planet. It's a phenomenon where continents teeter on the precipice of division, where new lands, islands, and oceans await their birth. In the crucible of this colossal shift, our world stands at the brink of transformation, and the implications are profound. Why is this ancient landmass, rich in history and culture, splitting asunder? What geological forces are driving this monumental shift, and what consequences will it bring to Africa and indeed to the entire world? Join us on this extraordinary journey as we unveil the awe-inspiring narrative of Africa's split into two continents, an unfolding saga that remains hidden from the awareness of most. Welcome to Universal Narratives, where we unravel the untold stories of our ever-changing world. In 2005, the world witnessed an extraordinary geological spectacle unfolding in East Africa, an event often referred to as a continental rift. This fascinating phenomenon occurs when a continent appears to be on the brink of splitting or separating into two or more parts. Yet it's a natural process that has shaped the continents we know today. To fully grasp the magnitude of the East African rift, we must embark on a journey hundreds of millions of years back in time. In the remote past, our planet was one solid landmass surrounded by a vast ocean. This enormous supercontinent was known as Pangaea, encircled by the immense Panthalassic Ocean. Over countless eras, the Earth's outer crust underwent cycles of heating, cooling, fracturing, and reorganization, eventually leading to the formation of the continents, islands, oceans, and seas we recognize today. Despite appearances, our planet is in a constant state of movement and transformation. The Earth's outer shell, scientifically known as the lithosphere, consists of roughly 20 tectonic plates that are continually shifting, either coming together or moving apart. These colossal plates are akin to fractured shell pieces floating on the molten rock beneath the Earth's core, which is intensely hot. The driving force behind this ceaseless movement is the Earth's internal heat, acting upon these plates. This perpetual movement of plates, commonly known as plate tectonics, is responsible for the creation of vast landmasses, including continents and islands. A striking example is the alignment between the eastern coast of South America and the western coast of Africa, a relic of a time when these territories were joined. In the case of East Africa, an extraordinary geological phenomenon of epic proportions is unfolding. The Somali plate to the east is gradually pulling away from the larger and older Nubian plate. At the same time, both the Somali plate and the Nubian plate are drifting away from the Arabian plate to the north. This complex interplay culminates in the Afar region of Ethiopia, giving rise to a Y-shaped rift system known as the East African Rift. Stretching approximately 3,500 kilometers from the Red Sea to Mozambique, the East African Rift represents a geological marvel. If the Somali plate continues to separate from the Nubian plate, it could ultimately lead to the splitting of the second largest continent in the world. However, this transformation, estimated to take between 5 to 10 million years, extends far beyond our lifetimes. There are also possibilities other than the complete separation of a continent. An alternative scenario involves the partial separation of the Somali plate, creating a new sea between the two land masses. This remarkable shift could open economic opportunities, particularly for landlocked countries like Ethiopia and Uganda, as the emergence of a new coastline offers new prospects for trade and development. Geologists closely monitoring the East African Rift emphasize that, although its progress is undeniable, it is not occurring at an alarming pace. Currently, the plates are drifting apart at a rate of approximately 1/4 of an inch per year. This gradual process, akin to the rate of toenail growth, piques our curiosity and expectations, but does not promise dramatic changes in our lifetimes. The formation of rifts like the East African Rift remains a subject of scientific inquiry. A prevailing theory suggests that an increased flow of heat from deep within the Earth triggers thermal swells, observable in regions such as central Kenya and northern Ethiopia. These swells extend and fracture the fragile outer crust, creating a network of normal faults. These swells are attributed to mantle plumes, regions beneath the Earth's crust, where magma is hotter than the surrounding environment, causing the crust above to melt and thin. The formation of the rift is often associated with significant volcanic activity, characterized by eruptions along the rift's faults. These eruptions, often termed flood basalts, differ from conventional volcanic eruptions as lava flows across the land like a flood rather than erupting from individual volcanoes. The path of this lava during these events forms a prominent feature of rift valleys. Rift valleys, like the one in East Africa, are flat regions created when tectonic plates separate, a process distinct from the formation of river valleys or glacial valleys caused by erosion. Rift valleys commonly develop at triple junctions, where three tectonic plates meet at angles of approximately 120 degrees. Two arms of these triple junctions may pull apart to create an entire ocean, while the third arm, often referred to as an oligocone, can become a rift valley. These phenomena are not limited to the land. Underwater rift valleys are equally prevalent. They often bisect long underwater mountain ranges and result from the separation of tectonic plates on the ocean floor. In these situations, magma rises from deeper levels of the Earth, solidifies upon contact with cold water, and forms new oceanic crust on the rift valley's floor. An iconic example is the Mid-Atlantic Ridge, where the North American Plate and the Eurasian Plate are pulling apart, creating an underwater rift valley known as the Mid-Atlantic Ridge. This phenomenon extends to the Pacific, where the East Pacific Rise has created underwater rift valleys. Rift valleys often host hydrothermal vent systems, a result of the underlying geological activity releasing heated water and fluids into the surrounding environment, creating a unique ecosystem. In the context of the East African Rift, the main branches include the Western Rift and the Gregory Rift. These rift systems host a myriad of volcanoes, from Ethiopia's Erta Ale Mountains to Kenya's Mount Kenya. The Western Rift is also known as the Albertine Rift or Lake Albert Rift and contains the Great Lakes of East Africa. This rift is notable for higher volcanic activity. The Gregory Rift, stretching from the Red Sea to Mount Kilimanjaro, is characterized by the presence of the Afar Triple Junction. Here, the Horn of Africa traverses the Red Sea and the Gulf of Aden, with all three tectonic plates moving apart. The arm of the Gregory Rift continues to widen through the process of oceanic crust formation. This transformation could lead to a seafloor depression so deep that the Arabian Sea could inundate it, turning the Horn of Africa into a continental island. Interestingly, despite sharing the same formation process, the Western Rift and the Gregory Rift exhibit distinct features. The Western Rift has deeper basins, hosting large lakes and sediment accumulations. Lake Tanganyika, the second deepest lake in the world, is one of the most prominent examples. Conversely, the Gregory Rift is characterized by more intense volcanic activity. These lakes result from the filling of rift valleys with fresh water. For instance, the ancient splitting of North America led to the formation of Lake Superior, resting on one of the world's oldest and deepest rifts. Similarly, Siberia's Lake Baikal is the world's deepest and oldest freshwater lake, with a rift floor exceeding 3 miles in depth. These lakes are fascinating natural laboratories that provide valuable insights into Earth's geology. However, the East African Rift is much more than a geological spectacle. It is also a paleoanthropological treasure trove. The region has yielded numerous hominid fossils, including Lucy, a humanoid skeleton over 3 million years old found in Ethiopia, and Turkana Boy, a nearly 2 million-year-old humanoid skeleton discovered in Kenya. Experts believe that the unique environmental conditions of the rift, characterized by alternating seasons of rain and drought in response to climate changes, played a role in human evolution, driving our ancestors to adapt and evolve. Furthermore, the East African Rift offers exciting opportunities beyond its scientific significance. It has the potential to serve as a source of sustainable energy through geothermal power generation. The United Nations Environmental Program is actively exploring ways to harness the heat generated by underground rift activities to produce electricity. A single geothermal well has the capacity to power thousands of homes, offering a promising solution to the region's energy needs. As we contemplate the future of the East African Rift, one thing remains certain. It is a captivating geological phenomenon that continues to shape our understanding of Earth's dynamic and ever-evolving nature. Whether it leads to the splitting of a continent or provides new insights into human evolution, the East African Rift will undoubtedly remain a universal narrative of Earth's dynamic and ever-changing nature. Thank you for joining us on this incredible journey. If you enjoyed the content and would like to stay connected, please don't forget to click the subscribe button and give us a thumbs up. Your support is essential to us, and we look forward to bringing you more exciting videos. Join our growing community today and be part of the adventure.